we'll talk about prisms and cylinders. Okay, so very similar to what we talked about with the nets. The base of your prism, okay, the base of your prism is always going to be the end cap. So what shape is my base?
Pentagon.
Pentagon. So in this case, we have a pentagon as our base. And then, so what are the faces then? That's going to be your rectangles, okay? It's like the sides. And by the way, when they talk about the height of a prism, we'll talk about that today. The height of a prism is the length of the prism. So you might want to make a special note of that on your sheet. And the height of the prism is the same as the length of the prism. Matt, write that down. The height of the prism is the same as the length. And we have a nice little formula. All right, rather than having to go in and unfold every single one of these, Nick, it really helps to be able to simply write down a formula and then plug in numbers and go. It really kind of speeds up our process. And so if you guys look at your Ames reference sheets that were passed out, so one of the other reasons why I passed those out and gave you guys a new one is because all these formulas are on there. So first, I want to talk about lateral area. And lateral area is the area of the sides. That's it, just the area of the faces. That does not include bases, just the faces. No bases, just the faces. So lateral area would be this nice little formula, the perimeter times the height. Now notice that's P sub B. What does that capital B represent?
Base.
The base. So it's the perimeter of the base times the height of what? Of the prism. Okay? Height of the prism. Let's look at that for a minute. Where did that actually come from? Let's go back to our little net right here. And I know we didn't really do this one, but it's fine. Right here we have a triangle, correct? And therefore we have 3 rectangles? Because that we have 3 sides to our base, right? Okay, so if I fold this up, the length of AC becomes the length right here, doesn't it? And then the height doesn't change, no matter which rectangle I have, the height doesn't change. So therefore, if I add up the area right here, I have this side times the height. So I'm going to call that rather side 1. So the side 1 times the height, plus side 2 times the height, plus side 3 times the height. And what do all these have in common? They all have an h. So if I take out the h, 1 to a side 1 plus side 2 plus side 3, which gives me what? That's the perimeter times the height. So that's kind of where that comes from, right? It's not just some random formula that's just thrown out at you. There is some rhyme or reason behind it. All right, so we got to find the lateral area. So we already talked about it. Let's move on to this one. So now total surface area. So again, if you look at your Ames reference sheet, that's given to you with a T. Oh no, they did change it to SA. It used to be as T for total surface area. So lateral area is just the area of the sides, right?
Yep.
But surface area is everything. So if I'm doing this, I'm doing the area of all these rectangles, all 5 of my rectangles, plus what else?
The 2 bases.
Plus the 2 bases. Therefore, if you notice, it's the lateral area, the PV, so the perimeter of the base times the height, plus the area of my 2 bases. And I know you guys complained about Thursday and Friday having to do the area of the polygons, but this is why we had to do that. Now this is what allows you to find the surface area of prisms, regardless of what the base is. Once again, if I give you some limited information on the pentagon, you should be able to piece it together and find what the area of the pentagon is. Now cylinders. Is a cylinder the same thing as a prism? For you say no? Why?
Because the cylinder only has basically one side.
Only has one side, or does it have an infinite number of sides?
It has infinite.
One side or infinite sides?
It's infinite because like just yeah. So we'll just keep going.
It's weird. It is actually the same thing as a prism,
I know.
but it's a special prism.
Sure.
What makes this prism special?
It's a special.
Does it have-
cylinder prism?
No, does it have a polygon as a base?
No,
What
it's
does
a
it have
circle
as-
as a base.
It has a circle as a base, but it basically is a prism.
Yeah.
Because remember, the sides of the prisms are rectangles, right? So I'm going to take this piece of paper, this rectangular piece of paper, and I turn it into a cylinder. All right, here's my cylinder. You guys agree? And I got my circular base, right?
Sure.
Okay.
It's like a cone.
But if I take that cylinder, sorry. But now if I take my cylinder and I unravel it, what shape do I have?
A rectangle.
So a rectangle. Okay. So really, a cylinder is a prism. It's a very special type of prism in which the base is a circle, which means the formulas are exactly the same. Look at your reference sheet. Look at the area formula for a prism and the area formula for a cylinder. Do they look like they're the same? Everybody should have one. I gave you guys out new ones last week.
Oh, you're talking about the paper, yeah.
I like it.
How do you find the lateral area of a, or basically, what's the surface area of the cylinder? Who has that formula?
So is T equals
Go ahead.
8?
Well, that's for a prism.
Oh, yeah, I thought you said
But for a circle, what do we have for the formula? No, it's just for a circle. Cylinder, guys. Look for the surface area of the cylinder. Should be on page 1. Two pi r squared plus. Okay. And so we have the height of the cylinder, and then we have the radius of the cylinder.
Wait, the surface area that I
Okay.
is like.
Now hold on. Didn't we just say that the surface area of a prism is 2 times the area of the base plus the perimeter of the base times the height? Did we just say that? Well, what shape is my base in a cylinder?
That's rectangle.
It's a circle.
Circle.
How do you find the area of a circle, Alexis? Pi r squared. How many of those do I have?
7,
So I actually have my 2b right here.
7.
Pi r squared. And I have 2 of them. There's my 2b. What's the perimeter of a circle called?
Circumference.
Circumference. What's the formula for circumference?
2 pi
No, no
2
square.
pi r.
Just 2 pi r. And therefore there's your perimeter. It's the same formula. The only difference is it's been adapted to deal with the circular base rather than a polygon base. But it's the same exact formula. It's twice the area of the base plus the perimeter of the base times the height. So which one of these two is the lateral area? 2 pi r squared or the 2 pi r h? The 2 pi r h. Alright, let's get into actually doing some stuff. Talk a little bit where the formulas are, talk about where they come from. Alright, let's do a couple of examples. Okay, first of all, let's name these. What type of shape do I have on number 1?
Trapezoid.
Trapezoidal prism.
Trapezoid.
Trapezoidal prism.